Hi, a viewer called Chris asked would I be able to have a look at this Victron Energy Phoenix battery charger. Now this came off a boat that Chris bought and he said it's totally dead. He's had a poke around inside of it, he's took the top off, checked the fuses and everything, and he can't see anything wrong, so he wondered whether I'd be able to have a look at it, see if I could figure out what's up with it. So the power comes in the bottom through one of these ports here. And it looks like to get into it we need to remove these 4 screws here. So let's remove those. Just grab a Phillips screwdriver. Right, let's see if this top comes off now. I'll get that out of the way. And what do we have in here then? So I guess that's the brains of the unit, let's say. So we've got a microcontroller there. And some networking type port there, RS485 or something perhaps, I'm not too sure on that. That looks like where the power comes in. And it looks like we've got 4 20 amp fuses on the output there. Looks like it charges 2 batteries. So we've got battery 1, battery 2 and a negative connection. Right, I think I'll get some power under it. We'll just see what it's doing first. I'll use the dim bulb tester, which I'll just get out shortly as well, just in case it decides to blow up on the bench. Right, I'll just go and sort that out. And resume. Right, I've got the dim bulb tester set up, which is just a bulb wired in series with the outlet sockets here. And what that's for is in case this shorts, it'll just make the bulb light up. In theory anyway, and hopefully it doesn't blow anything up. So let's switch it on and hopefully it doesn't go bang. Well, it is drawing some current because the filament is lit up very slightly. So let's check what we've got going on. I'll just put the meter here. And it's sunny today, as you can see outside. Right, I'll just go on to volts AC and we'll just measure what we've got coming in, and always be very careful when working on main stuff. Might not be best to copy what I do, just in case. And we've got 241 volts coming in there. Let's see what we get on the output. So swap those leads around. And we don't have anything. Let's just switch it off for now. And let's just check these fuses. And so we'll just go on to continuity. Yep, so all of those seem okay. It looks like it comes down here, goes through the fuses. So let's just check from there to there. Yeah. So I think the next thing we're going to have to do is try and pull this board out. So I'm not sure how that's held in. It looks like we've got a couple of big screws up here. And a couple of big screws there and a couple of screws there. I'll have to disconnect the power cable again though, so I'll just unplug it in a second. Just get out of the way. Let's disconnect the power cable. And let's start removing some of these screws, see if we can get into the thing. I'm not sure if we need to remove those 2 as well. Looks like it. Let's see if well, that seems to want to do something. There's a fan there, I think. Right, I'll just see if I can carefully get that board and get that out of the way. And then I'll get this part out of the way so we can have a look at this. I'm just going to handle it carefully just in case there's any live capacitors in here. Right, let's just flip it over and see what we're dealing with. It looks like the mains capacitors are in the centre there. Let's just zoom down a bit. Right, so it looks like the high voltage side is over here. And it looks like we've got a big inductor here. I guess this has got power factor correction. So we've got a main fuse here. Let's just check that. And I would assume that'll be intact because it was drawn power. So I'm just going to do continuity. Yeah, that's okay. Right, let's just zoom down a bit more. It seems to have a bit of a conformal coating on the board, which makes it a little bit harder to see what's going on. Let's see, it looks like we have a, right, okay, so I'm just looking here, I'll just try and angle this board a bit better. So it looks like we've got a bridge rectifier here, then we've got two transistors or MOSFETs, and then that looks like a diode. So I presume that this part of the board here is probably to do with the power factor correction with this inductor here, and maybe these four here are the main power supply, which will be that transformer there. That's kind of what I think anyway. Let's see where it goes after that. It looks like we've got two big inductors on the output. I'll just spin this board around a second. And I guess those are the rectifier diodes from the output. Just here and here. Maybe some regulation there. Looks like we've got a couple of big current sense resistors. And then we've got a couple of more transistors here. And we've got some of those resettable fuses. And another diode. Now I can't see anything obvious up to now. I've got a lot of current sense resistors there. Yeah, they must be on the output, because it looks like it goes to that point here, which I think was one of the, I think that was the negative battery terminal if I remember. I mean, there's signs of little bits of corrosion here and there, which is not surprising seeing as it's been on a boat. There's things like here. Right, well I think the next thing to do is probably plug it in and we'll just see if we've got any voltages anywhere. So I'll just flip it over a sec, we'll just check the other side just while I'm zoomed in a bit more. Just first, just to see if we can see anything obvious on here. Wasn't sure whether that was a bit of corrosion or something there, but looks like we've got an op amp here. And that Maxim chip there, I'm not sure of the number on it, but that'll be some kind of data transceiver for this port here. And that's the main microcontroller. Probably some kind of PIC chip or Atmel, I would think. Little crystal oscillator there. Right, I shall hook it back up and then we'll check some voltages. Right, I've got it hooked up with the power, but it's not switched on yet. I'm thinking, can I get this controller board out of the way, maybe over this side, so we can actually see what's underneath it. So that just goes to the little fan there at the front. I'll just see if I can undo these little plastic peg things. There's one hidden under here. Well, not really. It looks like there's a couple of, I guess they're temperature sensors or something that go underneath. So that looks like the main caps. Yeah, that looks like the main caps across here. I think I was at the, actually no, that might be the inductor. So I guess the caps here. Just hold on a sec. Right, so we've got a capacitor there and a capacitor there. Right. Let's see if I can get the meter in shot. I'm just going to volts DC. I'm just going to plug this in now and switch it on. And hopefully it doesn't go bang. Right, the dim bulb light is just lit up a little bit there. I'll just zoom out so you can have a look. So this is now live, so let's see what we get on those capacitors. So we've got 164 volts on that one. I don't think we've got anything on that one though, it's a bit odd. So why haven't we got anything on that one? Let's just see, so that's the bridge rectifier there. So I'm not sure if the AC comes in on the centre two pins or the outer two, it must be the outer two pins of the DC then, so let's see what we've got on here. Let's go on to AC. I've got 240 coming in. So I'm just trying to see where the... I'm just going to switch it back off a second. And just see if those capacitors are discharged. Well, they discharge rather rapidly as well. I was just going to have a look where the input comes in, but those capacitors didn't have to discharge rapidly. I'm just going to double check that we haven't got any voltage in those. .250 volt, 470 microfarads. I wonder if it's something like the mains caps have failed or something. Let's just see if I can see the pin out on this rectifier here. No, I can't really make it out. Let's just check that we've got continuity. From the mains going to the rectifier. So we've got 6.6 ohms from there to there. And 0.5. So the centre two are the AC coming in, and the outer two are the DC. I'm just going to switch it on again. I'm just going to see what the DC voltage is on those two end pins. Right, I'm just going to volts DC. I'll just switch it on again now. Oh, there we go, 330. I think it's the conformal coating on this. It's just a bit awkward to get your probes, and there we go. So 330 volts there. But why haven't we got anything to that capacitor? Oh yes, we have. It's the conformal coating on the board, that's what's throwing this off. Yeah, we're at 164 volts there. Let's try this one again. Yeah, 164 volts there. Yeah, I had to really poke the leads in there to actually get a reading. So that's a little bit concerning. It's not going to be the easiest thing to take measurements on this, is it? So we know the circuit's alright up to the capacitors here, or appears to be. I mean, I can't hear any noise, I can't hear any oscillations or anything on the power supply, so any whines or anything. So let's see if we get any voltages around about this part here. So I'll just go on volts DC again. I guess. Right, so that's one of the outputs there. So we're not getting anything there. Am I getting anything between those? Nope. And we're not getting anything here. Right, I'm going to switch it back off again. Just going to see if I get voltage on those. Yeah, so there was voltage in those capacitors. So at least you know the mains capacitors are okay. You can see discharge in there. Let's just try this one. So it looks like the power input side is the problem on this. I mean, it could be sensing a short or something and shutting down, but it doesn't appear to be doing that. I think it's something on the driving side. Right, I think it's time to start checking some components then. I think I might just, that's a bit awkward to work on this with it being like that. So I'm worried when I flip it over I'm going to be crushing all these LEDs and things. And I notice there's a couple extra buttons here. I think those must be for setting some internal settings or something on the thing. Right, let's just flip this over. Now let's just zoom down a bit on this part. Let's see if we can see what those chips are. Let's see if I can just zoom down a fraction more. So that's the UC3853N. I'm not sure if I can make the number out on that one. I'm just going to try cleaning that off with something, some IP or something like that. So I guess that's probably the main switching IC. I see something there, looks like UC again. scrape some of this conformal coating off. It's almost like varnish. I'm just going to have a look through a little spyglass, see if I can see anything. UCC 3808N. Right, I'm just going to look those numbers up and then see if I can find a data sheet for them. Right, I've managed to find data sheets for both of these chips. So this one is a push-pull PWM controller, and I'll just bring the data sheet up so you can have a look. And this IC here is a power factor correction controller IC. Now I'll just bring the data sheet on that one so you can have a quick look. So on this IC here, we should have the voltage coming in on this pin here and ground on this pin here. So I'm just going to power it on, and I've got the meter in volts DC, and I'm going to very carefully just go on ground here. And we've only got 0.3 of a volt going to that, and according to the specs the voltage should be between 13 and 14 volts. So I suspect that's why it's not running, because we're not getting the voltage going to the IC. Yeah, only 0.3 of a volt there. Let's try and measure the voltage on this IC. And I think it's pin 2 and pin 4. So let's see if we can get on those. So this one is the ground, pin 4. And again, about 0.3 of a volt. Right, I'm just going to switch this back off. And I think we'll flip this board over and see if we can trace where those pins go to. Right, I'll just move this out of the way. And I'll just see if I can flip this over. And I might spin the board round so it's easier, so it's closer to me to have a look at. Right, so this is the power factor correction chip here. And we want pin number 2. Which should be this pin here. Right, I'll just zoom down a bit and we'll see if we can work out where that goes. And I can't see it going anywhere on this side of the board. It looks like this is a multi-layer board because I can see one of the traces there. But that's not on this layer, it looks like the layer underneath, I think. So this might be a bit fun to try and work out. Let's have a look at the other chip, see if we can make any head nor tail of that one. Which is this one here, I think. Is that it? Yes, this chip here. Right, so where's the power coming on that one? Right, so the power comes in on this pin here. And again, I can't quite see where that goes. This is going to be fun to try and trace this through them, because with it being a multi-layer board, I can't see where those pins go. Let's see if there's anything on the other side of the board. And not really. Right. And I don't think there'll be a circuit diagram for this, because that would be very handy if there was. I'm just going to have a look online quickly just to see if I can find a schematic for this. I doubt there is one, but it's worth a try. Right, back in one moment. Right, had a look online. Unfortunately, you can't find a schematic for this, but I had a little bit of an idea. I thought I'd try and shine a light under here just to see if it's easier to see any of the tracks. And it looks like the power for this goes to here, which is just the coupling capacitor in front. That's the ground and that's the power. And it seems to go to this transistor here. And that seems to shoot off up towards the other IC. And then also we've got a leg of this transistor goes sort of through here. Maybe through there and then to this slot. That's only problem, you don't have a schematic for anything. I mean, it looks like possibly AC was on these pins. I think there's a couple of diodes there, so possibly this is where the power comes into this part, maybe. Let's flip the board over and I'll have a look, see what's round about here. So I'll say we've got a couple of resistors there. There's a couple of diodes. And we've got a capacitor here as well. And that's that transistor. I don't know if that's just discoloured a bit there or not. It's hard to tell, just the varnish. That could just be the varnish on it, I don't know. What's this capacitor here? Because capacitors are usually good suspects, so what is that? It looks like 0.22 microfarads, is that? 250 volt? I think I might pull that out just to have a look. Let's see where it is in this circuit. I think it seems to be here, doesn't it? Trying to work out where I was here now. So it is kind of connected to this part. Let's pull that out and we'll just have a check of it. Right, I'll just get the soldering iron on. We'll just apply a bit of fresh solder first. Try and burn through the varnish. Right, let's get the little engineer solder sucker out. Right, that's it out there. Right, let's try the ESR 70 gold. And I'll just zoom out a bit. Now I'm not sure what capacitance this meter goes down to, whether it'll measure something as low as that, but I would have thought it should. So I'm going to try this other tester here. I'll see if I can get it to fit in. Well, I think that seems right. So it mightn't be that. Right, I think we'll just pop that back in. That's where you need an extra hand, isn't it? Just try and get a bit of solder on it first to hold it. I wonder if we can measure voltage around this area just to see what we're getting. Just going to plug it back in. And that's our voltage pin there. And ground was that pin there, wasn't it? I'm just going to double check I've got continuity to ground here. Yeah. Right. Just going to volts DC. We'll just switch this on. Right, we've got 0.3 there. Let's just try on that capacitor. We've got 104 volts there. So we do have voltage coming out of here. Where was that big resistor? It was down here somewhere, I think maybe there. I'm just going to knock this back off again. Right, so that resistor's there. I'm just going to switch it back on. Let's see what will get either side of that resistor. So if I find my ground there, 210, nothing. Right, let's pull that resistor out. I'll just switch that off a second. Just give it a moment to discharge. Actually, I might use that capacitor discharger that Dan kindly sent me. Let's just discharge these caps. Right, add a bit fresh solder again. Right, it just fell out underneath here. So what's that? Is that 100k, I think? Let's just go on to resistance. Yeah, I think that looks alright. So not that. Seems strange how we're not getting any voltage going through it though. Right, it might be a bit awkward to get this back in and try some tweezers. I think I'll have to clean that bit of solder off the end of it first though. So what next? Right, I'm just going to zoom down a sec. I wonder if there's a short between the supply and ground. That would give us 0 voltage, wouldn't it? So let's measure resistance. Just see if I can get the meter in shot a bit there. I might have to zoom out a fraction. So that one was the ground and that one was power in. Yeah, 99k. So does one of those go to this resistor then, let's see. It's just with everything having this coating on it as well, it's making it twice as hard. And not at that end. And not that end. So one side of the resistor is ground by the look of it. And that will be why I wasn't getting any voltage there, but just on one side. So this must just be like some kind of pull down or something resistor then. Now I know that transistor, but then again I don't think we're getting power to that transistor, were we? Let's see if we get power to that transistor. Because that's on the same path. And just thought we'll try and get the meter and shot at the same time. Right, just going to switch it back on. So ground, I think, is this pin here. Let's go into volts DC. Let's see what we got on that transistor. 0.3, 0.7, and 1.4. That's 0.3 is the same as the voltage. I would have expected a higher voltage on one of these other pins perhaps though. I think maybe that one. So I think maybe the 1.4 comes from then. That's the middle pin there, isn't it? Again, you can't quite see with it being a multi-layer board. So it comes from down the bottom here. Well, that's bizarre as well, because if you notice, it comes from here, goes through there, and then to that capacitor again. And that's the resistor that I took out. So I definitely think that the problem's around here somewhere. Now, so if you had a schematic diagram, it'd be a lot easier because then you'd know what's connected to what. Let's just see if we can find out where voltages come from again. One here for ground. I'll just zoom out a fraction because you can't see the meter. I just realised. It's only problem when you're trying to do a video and you get engrossed looking at things and you're not really looking at the camera. So if I go here, you can see we've got 104 volts. 104 volts. That's this coating again. 104 volts. 1.4. So there's either a short on this line maybe. I wonder if it could be that transistor. What we could do is pull that transistor out and then see what voltage we get on this line. I think I'll do that. Right, I'm just going to discharge it again with the capacitor discharger. Oh, that all happened there. My monitor kind of went off there when I did that. I didn't like that. Just going to zoom down a bit more there. Right, the transistor is out. And again, I can't see any markings on it because of all of the varnish stuff or conformal coating that's all over it. So I've tried cleaning the stuff off the transistor. I've scratched it up a little bit. But it seems to be an A27, so I think that's an A27, so MPS A27 I think that is. I'll just see what happens when we measure it or test it. And it actually seems to test okay. Right, I'll pop that back in then. Now I know that one's the base of the transistor. And that's the collector, which goes to here. So does that mean the power comes from this side? Now I'm a bit confused because it only looks like this here goes to there. I mean, there's another component here. I'm not sure if that's connected to there or not. So I wish I had a schematic for this, it would make it a lot easier. No, that doesn't go to there. I think the battery's going in this torch. I can't see where else the power comes from. Unless... I'm just trying to think whether the power supply starts up first and then feeds the power factor correction circuit. I'm going to clean this up a little bit with some IP and then we'll start having a look at the power supply bit. But I would have thought it would have came in from here. It's just a bit hard to trace through everything. Give that a clean up first. Let's see if I can try and work out where the power comes in on this chip then. Again, multi-layer board. So that looks like the power track here. Where is it? There. That looks like it goes to here. To here and to here. And also goes through there. Let's see if we get continuity from there to there first. Yes. So that looks like it goes to the ribbon cable. But I mean, I suppose once the power supply is running, it gets feedback from the transformer. So that might be the main power that powers the front display and the rest of the microcontroller and that and stuff as well. Because it looks like there's a couple of windings come from the transformer here. One there and maybe one here. I think that bit came out of here. I guess that's a little temperature sensor. Finding this one a bit hard to trace through. So I just thought I'd try a little experiment here. And what I'm doing is injecting 14 volts into the supply of this chip with a bench power supply. Because I was wondering, has this chip failed and that's why it's not working? You know, it might be getting a brief startup voltage and then not kicking in because the chip's failed. And I'll show you what I've discovered. So if I just go on to volts DC with the meter here, you can see there we're getting 14 volts to the IC. And if I just go over to the scope here, these two pins here and here are the output that controls the MOSFET. So we'll just go onto this pin here. You see we've got a waveform there. There we go. And if I go onto this pin here, which is the other output, again you can see we've got a nice waveform here. So the chip is actually working. So the problem is we're definitely not getting the supply to start up the chip. But the problem is I don't know where it comes from. I've been trying to trace through the circuit, but because it's a multi-layer board and it's got like heavy sort of ground planes in it, you can't actually see where all the traces go, and it's a bit hard to follow where this supply actually comes from. So I'm struggling a little bit with this one at the moment. So I've spent ages on this trying to figure out the problem. And one of the things that I did come across, because I tested all the diodes, was there's a diode here, and when you measure it, if I measure it the other way, so I removed the diode, tested it, and it's okay. What the cause of the apparent short is there's a 27 ohm resistor across here, that's across the diode. So it wasn't that, and then I'll show you what I found next. So I thought I'd have a look at it through my little magnifying glass. I'm just showing you through the microscope here. And I noticed this resistor here kind of looks a bit burnt around the edge there. But that measures okay as well. There's actually another resistor I think looks quite similar as well. So I think it's just the coating wasn't applied on them properly. I can't find it at the moment, but anyway. So there was just another resistor looked quite similar to that as well. And that one measured okay as well. So not that. So I thought the power might have came in here because we've got some diodes here. And then we'll go through a couple of resistors. We'll go through this big resistor here that's across this capacitor here. And then we've got two resistors here and two resistors there. So these ones are the smoothed output, and these ones are not smoothed. So this one seems to go to the current sense pin for the mains. I'm not sure where the other one goes. It disappears off over here somewhere. Actually, it goes to the base of this transistor here. So what I think happens is once the power supply is up and running and we've got power to the base here, it then switches this transistor on, which then powers up this IC. So I think that's the way it works. But then I was a bit confused where this IC gets its power from still. So I've been trying to trace it through. So the power pin is this pin here, which seems to disappear off over that way. Now you can't see it, but it's actually joined to that pin there as well. So if I just put the meter into continuity, or diode check this so you can hear it. If I go from here to here, we can hear it actually goes to that pin as well, but you can't see the trace. You might just be to see it very faintly there. But because it's a multi-layer board, it's very hard to try and trace things through. And that seems to go over to here. And then it goes through a resistor. And then it goes up to here. And then goes through another resistor. Through another resistor. And on this pin here, we've got 300 volts DC. So I think one of these resistors might have failed, because we've got 300 volts here and literally nothing here. So I'm going to flip the board over and we'll have a look at these resistors on the other side. And one of the wires came off one of the little heat sensor things there, temperature sensor, so I'm going to have to sort that out as well. Now I'll just flip this board around. Let's see if we can locate those resistors. I'll zoom out a fraction. So I think it's those two there. Now I did a look at that one before because I thought it was discoloured, but I wasn't sure if it's just varnish on it. So I think what I'm going to do, I'm going to unsolder those two and then we'll test them. Right, I'll flip the board back over, we'll desolder those two and we'll see if they measure okay. And hopefully it's one of those that's failed. Right, let's desolder those. Not sure if they want to come out. Right, well there's one. Let's see if I can get the other one out. Right, that's them both out. Let's move this out of the way a bit. Now hopefully one of these has failed. Because if not, I'm not sure what else it can be. I'll just get the meter in shot and we'll just zoom out a fraction. Well, 100k. Hopefully this one's open circuit. I think I found it. Yes. Yeah, 100k. Open circuit. Yes. Oh, I'm so relieved about that. I've been on with this thing for hours. I'll just zoom down a bit more. I don't know if I can get a bit more light on these. I might get these under the microscope actually. But yeah, it's very, it's more like the, I thought it was more the varnish on it is discoloured. But I don't know if that's a mark on the underneath of it there. I might get the microscope in on these just so we can have a bit closer look at them. I had something similar like that happen on the Kenwood mixer I looked at, where there was a resistor, similar sort of thing, that wasn't burnt but it had failed. I'll get the microscope set up. Right, I've got the microscope set up, and if we notice on the resistor there, there's a little bit of a crack on this side. Now the only thing is, this is the actual good resistor, this is the faulty one. So I kind of fooled you there, sorry about that. And I can't really see anything on this one. It's just got varnish on it, that's just a little bit discoloured. I mean, I don't know whether there's a slight discoloration there. I don't know. It's even got the same crack in the same place. It's even on this side as well. Well, I can't really see anything on there. There might be a slight little bit discoloration just between those two bands there. I mean, when I looked at this before, I just thought it was just discoloration on the varnish, just there. Right, let's see if I can find some replacement resistors, pop them in and hopefully get this thing up and running again. Right, found a couple of replacement 100k resistors. And just to show you about camera angles and things, it looks like that's almost touching this metal here, but when you actually look at it properly, it's miles away. Right, let's see if we can get this one in. Right, so just bend those legs a bit, I think, so they don't fall out. Right, let's get those soldered in. Just cut off the excess. Right, now I need to sort out that wire that came off, which was from in here. I think I'll put a bit of hot glue on that. Something like that should probably do it. Right, that glue's gone hard now. Let's just zoom out a bit. And plug the fan back in. Right, let's zoom out a bit more. Let's try and shift some stuff out of the way a bit. Right, I'll get the dim bulb tester. Right, let's see what it does now then. In 3, 2, 1. Oh, I think that's it. I heard the fan kick in and it started going. Obviously it wasn't running on full current and that's why it was switching the bulb, and that's why the bulb was flickering. So I think what I'll do, I'll reassemble it and then we'll just try it direct on the mains, and then hopefully, fingers crossed, it all works. Right, I'll just get this back together then. Right, that's it pretty much back together now, just apart from the front lid. But we'll not put that on yet because we want to check that we've got battery voltage on the output. So we shall bring the test meter in. I'll go into volts DC. Well, I'll plug this into the mains. Actually, I'll put it on standby. I'm going to plug it into the mains now. And I heard the fan briefly power up and go off. So there's something else gone. I wonder if it took those resistors out again. Because it's doing pretty much the same as what it did before now. Yeah, we've got voltage going in there. I'll just switch it off a moment. That was standby. And that's charge. So I'll just give it a moment for the capacitor to discharge and we'll try switching it on again and see if it does anything. I thought we had it sussed there. Well, that's a disappointment. Right, got it back on the bench. Not that I actually left the bench, but let's just see what those resistors measure, see if they're going to open circuit. Looks like there might be a capacitor or something. A bit charging still, possibly. I'm still getting readings on both of those resistors, so I don't think those are going to open circuit, so I don't think it's that. I think I'll couple it back up to the mains and we'll see what voltage we get on the switching IC. Just checking in case it was a dry joint or something on that connector. I think I'll just quick look at that. Just quickly check the soldering on the back of that just in case. No, it looks okay. Just want to check the mains fuse, it's still intact as well. Yeah. I'll try back in the dim bulb tester again. Let's check that's not shorting on anything. What? I don't believe that. Let's switch it on there. I'll try back in the mains. Huh? Well, that's a bit bizarre, isn't it? So it's starting to run if I run it on the dim bulb tester, but when I plug it into the I wonder if it's not that. No, it can't be that socket. I just wonder if it's a socket I'm plugging it into. I wonder if the socket's faulty. I just want to try different sockets. Right, so I'm just going to plug it in again now. Well, not the socket. I think it must have to reset. The capacitor's discharged or something. Oh, why isn't it running? I don't know why it's not running on mains. Direct. It's like it's sensing too much current or something and then shutting down. Hey, nothing's ever straightforward. So I've just been thinking about this. And there mightn't be a problem with this. It might just be user error. Because one thing I haven't got is a battery connected. So if I just measure the battery output here and just switch it on through the dim bulb tester, well, you can see the battery voltage climbs rapidly to about 15 volts. And I think when it gets to about 16 it switches off like that. So it might be the fact that I haven't got a battery connected to it to keep the voltage low, why it's powering off. So it's after midnight now, so I think tomorrow I'll get my jump starter. I've got a lead acid jump starter. We'll connect that up to the output and then we'll see if that charges it. Right, back in the morning. Well, I was right about it being after midnight. It's actually 1:30 in the morning. But anyway, I've been over the shed. I'm getting the jump pack because I thought I'll be awake all night thinking about this otherwise. So let's see if this works. So I'll just try it on the dim bulb test app first. I've got the jump pack switched on. So let's just check I've got voltage. Let's try and get this meter in shot there. Yeah, so I've got voltage there off the jump pack. Right, let's switch this on then. Actually, let's measure. That looks a bit more promising, doesn't it? Right, let's try it on the mains without the dim bulb tester. Right, here goes, fingers crossed. Oh. Well, I didn't like that. I don't know what happened there. But it definitely didn't like being plugged into the mains. I thought we had it sussed there. Why on earth is it not working? I wonder if I can get the test meter. Just to do that, and let's see if I can plug it in again. Yeah, the voltage shot right up there. So that's the problem. But why is it doing it? Right, I'm going to have to leave this one till the morning now because, like I say, it's getting late. So, right, I'll see you in the morning. So it's the following day. Let's see where we're up to with this thing then. So, what I've worked out, because I have had a quick look at this just to see if I could figure out what's going on. We've got this opto isolator here, and what that does, it provides feedback from this side of the power supply back to the main side of the power supply. Now this one that they're using here is a triac driver. One side of it is connected to ground, and the other side of it, you can see the trace comes all the way down here, comes down here, and it actually ends up on a jumper which is here. It actually goes to that middle pin. So I'll just flip the board over, I'll just show you the little jumper there. And the jumper is just here, which you can take off. So I thought, well, is the jumper in the correct position? So I had a look online and I found a picture of somebody else who was repairing one of these that was blown up, or trying to repair one of them. And the jumper's in the right place. So I thought, well, where does the jumper go to? It must go to the feedback pin or something. Well, I was actually quite surprised to find this out. I'll just zoom down a bit, and it explains a lot. Right, so this side here, I'll just try and get the meter in shot a bit. A bit awkward to try and get everything in shot here. I'll just zoom out a fraction more. So this pin here is ground, and if we trace it back, I'm just going to continuity, this pin here on the chip is the ground pin, and as we can see we've got continuity from there to there. Now this pin, when you trace it through, look where it goes to. It goes to the supply of the chip. So I think this is like a last resort sort of fail-safe type of thing. With it being a triac, it's actually across the supply of the switching IC. So what happens is once this gets above a certain voltage, it triggers the triac, which then effectively shorts out the ground and the supply to this chip, which is probably why these resistors are burnt out. So, because I was a bit confused how this worked, but that appears to be what it's doing. And because it's a triac and it's being used to switch DC, it latches on until the power drops, i.e. until the power's totally gone, before it'll switch back on again. That's why when I switch it off, it won't switch back on. It's actually got to wait for the power to drain, because the triac's in its last state, and it won't unlatch until there's no power there, because it's on DC. I just thought it was really odd. Right, so back to why isn't this working? Well, the only other opto-isolators that I've found are the two that are on this control board here, which come from the microcontroller, and if you notice they're in different orientations. So one of them, the LED's on this side, which then shines through and triggers something on this side of the opto-isolator, and on this opto-isolator here, the LED's on this side. So once this detects a certain condition, it then switches this opto-isolator, which has got a transistor in here, which I then guess triggers the power supply to stop going so much. Now this is what I've found. So what I'm going to do, I'm just going to measure the voltages. We'll just measure on this side of the opto-isolator so you can see which pins I'm on there. So this will be the transistor. So what will happen is once the power supply sends a signal to the LED, it'll switch this transistor. So there should be power there for it obviously switch on and off. So I'll just go into volts DC, and I'll just switch this on, and hopefully I'm on the, actually I've tried just go on the chip itself. So I think I had better results like that. And you can see there, we've got about 5 volts. Now if I go on to this opto-isolator, which is the opposite way around, so it's the same 2 pins in effect, and we just switch it on, we've got no voltage. So I would have thought we should have a voltage there for it either ground or something like that, but there's nothing there. If we measure the input, which is the LED side, I don't think I'm quite on there properly. It's a bit awkward to get on with this conformal coating. There we go. That's up to 1.2, which should mean that should be triggered. I think it triggers at about 1 volt. So that should be regulating the power supply, but it doesn't appear to be switching anything on this side. So I think we need to trace where this goes to now. Well, I still haven't gotten much further with this, but I just thought I'd try a little experiment here. I just wanted to see when this gets up to about 1 volt or 1.2 volts, what the voltage on the output is, because that's when it should be telling the power supply to stop switching. So if we notice there, I'll just do that again when we'll get to about 1.2 volts, and the power supply is about 12 volts, which is right. So this part of it's working, telling it to shut down, it's just not shutting down. Now I have done a little bit of a diagram where I've been working out. So this is the opto-isolator, which is just here. and it goes through a 1K to this pin here, which then goes through a diode to the supply to the switching IC. And this one here, which comes from the opto isolator, it goes through to this connector here, and then it comes out of the connector, goes through that 11K resistor, and then goes to the feedback pin. But then, when I've had a look at the feedback pin, it goes to other things as well, and it's got all of this on the other side. It's got all of this hodgepodge of, all of this goes back to the feedback pin, which is down here, which links to that pin there. So I've got all of this additional add-ons, let's say, I'll just zoom down a bit, in all of this mess here. Let's see, I started to try and pick it away just to see what components that are in here. So this has been sort of heavily modified at the factory for some reason, and I don't know why. You can see, but the feedback pin is this pin here, and it's got resistors coming off it and capacitors all encased in silicone sealant stuff. So this is turning into a bit of a nightmare, this one. So this is many hours later again now, and I've been tracing this circuit through, trying to figure out how this feedback section works. And I've just discovered something, so I thought I'd show you what I've discovered. I've changed that diode there, which goes to the pin, which then goes to the opto isolator. But I was trying to trace, because the supply voltage on the chip comes to this side here, but then it goes through the diode, or it doesn't go through the diode because the diode's blocking it. So I was thinking, well, what's all that about? So I thought, well, the supply must come from somewhere else. So I found out that it comes to the center pin of this transistor here. So I switched it on and I measured the voltage, and it seems like this transistor's switched on all of the time. So I thought, well, why is that? So then I've traced it back, and it seems to come up to here, to some more resistors and things, and I think there's a diode there. And then it comes to this little transistor here, and look what I've discovered. If I measure this transistor here, I'll try to for the conformal cone. Oh, it doesn't want to work now. There we go. I see this conformal coating. So that doesn't look right, does it? I think that transistor's shorted. So I wonder if this has been the original fault, and it's caused that opto isolator to kick in, which is then basically shorted across the supply to this chip, which has then burnt out those resistors over time. And I think that's kind of what happened. So hopefully, I'm going to take this transistor out now, and hopefully, fingers crossed, that's it. Honestly, I've spent hours on this thing now, so it has been an absolute nightmare. And you just can't trace things very easily. If I had a schematic diagram, it would have been a whole lot easier, but you know, such is life, I suppose. Right, so let's get some solder on this transistor. I even start pulling apart that modification on the other side just to see what all that was about. But that's got nothing to do with the feedback. It seems to be going to the gates on the switching transistors. So it must be something to just help with that, I guess. Let's see if I can get this thing out then. Right. I'll just zoom out a fraction. And we'll try the DCA55. See what it makes of this. Now whether or not I can identify the transistor or not, I don't know, because it's all covered in this goo again, so I might have to soak it in some acetone and hopefully get rid of this varnish stuff off it. Right, so hopefully this comes up saying it's a faulty or unknown component or something. Yes! Right, excellent. I'll see if I can identify what this is and I'll see if I've got one. Whew. So I thought I'd get this transistor under the microscope here. As you can see, it's just covered in this varnish resin stuff. You can't see any of them on it, so I thought I'd try a little bit IPA on it and then try and look at it, and you can just make out, I think it says BC 556, I think that's what that is. Yeah, BC 556B, I think that is. Let's see if I can zoom in any more. Yeah, BC 556B. Right, I'll see if I can find one of those. So I've had a look around and I couldn't find a BC 556, but I have managed to find a BC 327, which is slightly less voltage it can handle, but it's the only thing I've got to try at the moment. So if it works, I'll order the proper part, but we'll just try this just to see if it is that. So let's see where it goes then. Right, so it goes there. I'll try and get this in. Right, we'll get that soldered up. Right, I'll plug it into the dim bulb tester first. So I'll just zoom out a fraction. Right, let's see what it does now, if anything different. I wonder if that's just the same then. Oh. Well, that's different. I'm going to try it in the mains. So let's see what it does now. So this is without the dim bulb tester on. I've got a light on. It hasn't gone pop. Let's see what's going on. There's two lights on now. Let's see what we get on the output. 14.5. Yes. I just got to describe how happy I am that this is actually working now. I've spent nearly 2 days on this trying to sort it out. I know it's a long time, but I was just wanting to get it working and trying to trace it through, and then the conformal coating, and you're not sure if you're getting a reading or not, and it was an absolute nightmare. So I'm just going to connect it up with a battery just to make sure, just to see what happens with the lights. I'll just switch it back off a sec. I'll go and get my lead acid jump pack. Right, I'll just zoom out a second. Right, let's plug this on. I'll just switch this on. Let's plug this in. Actually, before we do that, let's measure the voltage. Let's just see what voltage we've got in here. 12.86. $14.4. Excellent. Right, so what I'll do, got the meter on properly there. What I'll do then, I'll order the proper transistor for this. We might as well replace it with the proper one, even though it is actually working. We might as well make sure it's back to the way it should be. And then I'll get it boxed back up and get it sent back to them. Right then, feature length video on this one, I think. So if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.